Hello everyone. Welcome to Computer Science E75. This is Lecture 5, Sequel Continued. My name is Dan Armendariz. I made a brief appearance at the first lecture. I'm the head TF for this course, and you haven't really seen me here much, but if you participate at all in the discussion board or sent emails to help@, you might have seen a reply from me. So here I am in the flesh, and we'll be talking about a little bit about SQL today. But before we get into that, I wanted to clarify something that seems to have caused quite a bit of confusion about the projects, and that specifically relates to the configuration that we use with regards to this projects folder. So as you know, you have an account on the cloud, on cloud.cs75.net. And within that account, we made for you a folder called projects, and that projects folder has subdirectories 0, 1, 2, 3, so on and so forth, including the final project. And it can be a little bit confusing, but we did this intentionally, not to confuse you. We didn't do this to confuse you, of course, but this was a very deliberate design decision that David and I made early on in the semester. And the reason has to do actually with the typical configuration that you might find in a standard Apache install, like what we see here. So typically, let's say that you buy a domain name and you have a host account. And so you point your domain name towards this host, and that website, that domain that you buy, will work with that host. So let's say you buy domain.tld and you point via DNS to your host. Now, typically, the host configuration that would be used is something that looks like this. And these are just directives that would be found in an Apache configuration file. And all it basically says is that there's a virtual host, which means that one server, one physical server, can be a host to multiple domains at once. It can just be a virtual host for multiple domains. So it's a virtual host for any IP that server might happen to contain at port 80. And it says that there's a server name. So this server name is how this server is able to differentiate between each of the domains. So in this case, the server name is set to something like subdomain.domain.tld, just as an example. Server admin is just sort of a typical directive. If something goes wrong and you see one of those Apache error messages, it always gives you a webmaster email address. That's that email address that you might see. Now, these are only a few of the directives that you might see. They could actually be quite a bit more involved. There could be more options that are set, but this is just sort of the bare bones minimum that you might see. Now, the important one that's here is document root. And this is really where it differs from what a typical Apache virtual host directive might be compared to ours. And I'll show you ours in just a minute. But this is something that you're probably familiar with. You have your own home directory, which might be in /home/username. And within that home directory, you have something like public HTML. And everything you put in that public HTML directory, assuming the permissions are correct, will be accessible via the domain that's specified here. So subdomain.domain.tld, you can put everything in there, and that's what will happen. And in fact, this really isn't very different from what we have now. It's just that we have a little bit extra detail based on the number of projects that we have. And I'll get into that in just a second. But basically, this makes sense because this has a very direct, very straight mapping of any directories that you place into this public HTML directory, act as directories in the domain, so on and so forth. It's a one-to-one mapping, and it makes a lot of sense. And the upside is that this is common. This is easy to understand, and a lot of hosts do this. But the downsides are that this isn't actually a very good tool for us in this class, because we have, this can actually increase the complexity, whereas before one of the ways that we did this was we had multiple subdomains that a person would have to create, one for each project. So you would create a project like, you would create a subdomain like project0.domain.tld, and you would point that towards our server. Our server would recognize the subdomain and point it towards one directory. Then you would have project1.domain.tld, and this got cumbersome, not only for you, the students, but for us, because it's more complex to manage. It's more difficult to have to deal with. The other downside is that if we had something like this, we can't actually do a very good job teaching you some of the better ways of enhancing the security of your web application. And that is that you really shouldn't place every single file for your project in the HTML or in the public HTML directory. There are some files that simply do not belong there because users have no need to see them directly. Sure, your project might reference them in the code, but it doesn't mean that the users are going to see them directly. So just as an example, this menu.xml, there's really no reason for a user on the internet to be able to go to this website and type in menu.xml and see the actual XML file that's powering the website. There's no need for it, and it could, in fact, make the security of your website a little bit less secure. It could actually impact it for the worse. So it's better to have these directories outside of the public HTML directory that can store these sorts of things. So like the menu.xml, perhaps you have a configuration.php file where you store some constants. One constant, for example, might be the location of the menu.xml file. It might be some definitions, some functions that you've created, any number of things that you share among all of the pages in your project, but you don't want the user to see directly. Now, if you have a site that's like this, most likely this site is relatively unique. It's meant to be one holistic idea rather than 5 separate ideas. So we have 5 different projects, and each of those are relatively independent. They're all meant to sort of be self-contained. While you can share some code between them, you're probably not going to be doing that a lot between these 5 projects. And so it becomes difficult to maintain something like this, where you have one lib folder outside of the public HTML directory, and now you're cluttering it with all of these files from each of your 5 projects. It becomes a mess for you guys, and also becomes difficult for us to figure out which of these files actually belong to your project. So we'd have to do something silly like copy over your entire home directory to be sure that we can actually see all of the projects. So in an attempt to mitigate these problems, we decided to do something that looks instead like this. And this is the virtual host directive of each of your accounts on the cloud. And so you'll notice that many of it is the same. The server name is the same, the server admin is the same, but the document root isn't a public HTML directory. The default is the HTML directory in your 0th project. And this is why if you go to your projects.domain.tld, just by itself, you see the same thing. You see the same web page that you would see if you go to projects.domain.tld/0. Now, the aliases are what's important here. You'll notice that we have, 5 aliases, one for each project. So if somebody goes to your subdomain /0, this, while it looks like a subdirectory within this document root, it's not actually a subdirectory. It's actually an alias, and this alias points to this folder, your home directory /projects/0/HTML. And the same thing for each of these projects. So in this way, everything that you place within this HTML directory in each of these projects folders, it's as if it is a public HTML directory for that project. So the idea here is that anything that you want publicly accessible, so for example in this most recent project, you would probably have a shopping cart page, and you'd probably have a checkout page, and you'd probably have a menu page that shows you a list of items, and these could be named different things, but each of these are user-facing pages, and they would be appropriate to be placed into the HTML directory. Now, if you were to have this menu.xml file, it's this, like we discussed just a second ago, this is not really a good idea to place in this same HTML directory. It's not something that the users need to see directly. It's something that your scripts will use in processing the final output, but it's not something that we would want users to actually see all the time. So for this reason, the whole point of us doing this is that we can have other subdirectories within this project/0, within project/1. For all of these projects, we could have etc and lib. And each of these can you store files that would be referenced by the files in your HTML directory, but will not be shown publicly to the user. So your menu.xml file, for example, would fit very well into the etc directory in your project/0, or rather project/1/etc. And if you had any common functions, for example, and you had all of these functions, you placed them into a functions.php file. This functions.php file doesn't need to be publicly facing, so you might put that into the lib directory. And the whole point of this is that what we're trying to teach you is best practices, that this is not something that you want to expose to the whole world, and putting it into 5 distinct directories like we have here allows us to do that while keeping them all self-contained, so that we can actually pull all of the data from project/1, for example, and we get your entire project. And so that's really what is going on here. And so it might be a little confusing at first because it's not a direct one-to-one mapping whereby you type in projects.domain.tld/1/readme, for example, and that readme folder does not actually exist in home username projects1 readme, but instead it lives as a readme directory in the HTML directory. So everything that is meant to be publicly accessible needs to go into HTML with the proper permissions. And the proper permissions here for directories, you generally want to have 701 or 711. One of those two will be fine. If you have PHP files, generally those are going to be 600. And if you have pretty much anything else like CSS files, non-dynamic HTML files, so in other words, files that will generate HTML, they're not going to be dynamic, so just static files, images, CSS, anything like that, that needs to be 644. And you can use the chmod command, chmod command, when you're logged into the cloud to make sure that your permissions are set appropriately. And in fact, you should make sure that every directory along this path, your username directory, projects, to HTML, all of these should be 711. Now you'll notice actually if you do an ls on your home directory, or rather in your projects directory, you'll notice that the non-HTML directories have slightly different permissions. The reason for that is that they're not exposed to the world. They're local only to you, so they have slightly tighter permissions than what you would expect from these here. Any questions on this? Yes? Which files, I'm sorry?
What's the Apache configuration here?
So this is a virtual host directive that exists, and there's one of these for each of your domains in an Apache configuration file somewhere on the cloud. And so it just exists in one of Apache's configuration options that we pre-generated when we received your survey. We created your account, created this directive, created the project's hierarchy, and then sent you an email. And that's how all of this happened. Any other questions? So everything, again, just to reiterate, everything that you want publicly accessible via your website has to go into the HTML directory within the appropriate project number. If it's not, you're not going to see it. You will get some weird error. Well, no, you won't get a weird error. You'll just get a 404 not found, or maybe even more cryptically, depending on your permissions, a 403. It really depends on what's going on. Okay. Any questions before we move on? Last chance. All right, I'm kidding. No, so of course, if you have any questions, do feel free to let us know on the Google group or at the help list. Okay, so coming back to SQL. So last week, one of the things that David talked about was how to be able to log in, or how to create a login form using some SQL technology. And really, it's all SQL is. It's just a database that allows you to store some values into a table that you've created, just like an Excel file, for example. You have a preset number of rows and columns that you've predefined. You can fill those rows and columns with data, and you can select for that data using MySQL. You can insert data, you can update data, you can do a number of things with it in your PHP files. So if we take a look at a slightly modified version of one of David's login files. So here we have, last week he showed you login 5 and 6, but I took these files and I modified them slightly to show you just how we can do something a little bit different with these. But basically these work the same. So what we are presented with when we run this file is a form. Or when not run this file, that's perhaps inaccurate. When we open this file in a web browser, we are presented with this form where we can enter a username and a password. And as you might recall, we can just enter in the correct username and password, hit login on this, and we are told that we are logged in. If we do not enter in the correct username and password, then we in fact get an error. But the important part about version 5a was that we actually can see how we can use MySQL to access some of this data. So, for example, we really have no need to query the database for any of this data until we're sure that we have received some post data. So if we have received a submitted form, then we will expect to have data in both the post post superglobal for the user key and the pass key. So we first check for that, and that's what this first if statement does. It checks to make sure that the user has actually submitted the form and that the user has submitted the form with both of these fields entered. Okay, then we connect to the MySQL database. And now this is actually where this code diverges a little bit from the login 5 that you saw last week. Instead of having the username, the host name, the username, and the password entered directly into this line of code, I instead am using some PHP constants. And these constants are defined in another file elsewhere that I've included up top. So you'll notice that here it's requiring this file called include.php. And before I mentioned that you might have a PHP file, like a configuration file that includes some constants that you might use throughout your program. This is one example that you might actually use. You might actually have some of these configuration options like the host name, like the username, like the password, and you might actually have them stored in a separate configuration file. And this configuration file is perfect for placing into that lib directory as opposed to HTML, because there's really no reason for someone to visit it. So if we take a look at that, if we just redirect a little bit, I actually have an example version that's where I just remove the password because I did this one year and somebody was smart enough to, and even though I used this MySQL username only for lecture, somebody in the audience actually logged into PHPMyAdmin and went ahead and modified some of the table stuff, and it was kind of funny, but I don't want to risk that again. That was sort of an interesting occurrence. Okay, so here we have these. We can see that we've defined the host, we've defined the username, and we just have, for now, a dummy password. But this is actually a very useful thing to do. You've defined all of these in one place, and now every time you require or you include this one file in any other PHP file, you will have access to these. And this is a great benefit because if you are using MySQL connections in a number of pages and you have to change your password or you have to change your username or your host, it's much easier to do it in one file than to do it in many. So having a configuration file is a good way of getting around a big change that you might have to do on a global scale. You'll notice that not only have we defined a host, a username, and a password, but also a database. And this is the database that we tell MySQL to use to query against any tables within it. Okay, so back to login 5a, just to go back through this again really quick. So we connect to the database. If that happens successfully, then we select the database that we had seen in the other one, danallen_lecture. Then we actually are going to create a query, the select star from, where we're actually going to query against the table that exists in this database. And in this one, we had sort of an interesting thing, and that is that the problem with this was that all we were doing is just verifying to see if the user existed in the table. So in other words, this SQL statement that's here says select any rows, or rather any fields from the users one table where the user is equal to the username that they had input. And this is really, really important, the fact that you take any input from the user and you run it through MySQL real escape string. This is absolutely, absolutely essential. Otherwise, you are exposing your program to risks for SQL injection attacks. And if they didn't talk about that last week, we certainly will in the security lecture in a few weeks. These are very dangerous attacks where somebody could either log in without having a username or password. They could go ahead and delete your entire table. They could do any number of things that you really do not want a person to be able to do. So using MySQL real escape string is absolutely essential whenever you're going to be accepting input from a user and querying the database with it. Okay, so then we perform the query using MySQL query, and we find out how many rows we get in the result. So if we get one row, then we assume that the user has logged in, and we go ahead and go through the motions of doing this. Now, obviously, this is not very secure because we're not actually testing to see if the password that the user had entered is actually the password that exists in the table as well. And so the part of the fix from 5 to 6 was for this reason. So now our SQL statement looks instead like this. So we select one from users where user equals %s and password equals %s, and we use sprintf to inject the MySQL real escape string result of the user input and the password input into those %s characters. So now the final result will be that this query will look like select one from users one, where user equals, and then whatever the user had entered, and the password equals, and then whatever the password is that they had entered. Now, this is much better, because now we're actually confirming that the login information that this person is using is actually valid, a valid username and password combination. But there is still something that's wrong with this. And what is wrong with this here? What is wrong with what we are doing? And it may not be immediately obvious. And what I mean by that is that it is not a direct result of this code here, but rather what this code implies about how the table is set up in MySQL. Right, exactly. We are not encoding the password. So if we were to take a look at the table itself, what we would see is that the password is just presented out in the clear. And I can do that here with, let's see. So this is, if you haven't seen this, this is PHP MyAdmin, and this is a web interface that allows you to run queries against your MySQL database, and you can view your tables, and you can see all sorts of information about your database. So here, if we take a look at what we see in users one table, we'll see that we have it defined with two fields, a user field and a password field, and you can see the usernames, which is probably fine. It's probably not that big of a deal that the usernames are in the clear. But we can also see the passwords. So now you know what the passwords are for this. And while you as a system administrator may say, oh, you know, what's that? You know, that's not that big of a deal, because now if somebody loses their password, all I have to do is, you know, just go in there and type a new one. But this is actually a pretty big security risk. If anybody else besides you sees it, obviously there will be a big problem. And also, a lot of users are concerned, and probably yourselves, about the people managing a system actually being able to see what your password is. As you know, passwords, people use all sorts, and I'm sure many of you are guilty of this as well. I am sometimes also, where you just use one password for a number of things, and if that one password gets out in the open, and you might even try to use the same username for a number of things as well, then that person might be able to access any number of services with that username and password. So it's really important to protect the password from everybody, including yourself, because then you have deniability, really. If something goes wrong with the table, you can say, oh, you know, the passwords were encrypted. They'd have to do something impressive to be able to do this. And so we need to, in some way, we need to be able to encrypt these passwords so that it's not obvious what they are. And there's a couple of ways that we can do this. The first way would be to use a MySQL function called password. And you might have seen some examples of MySQL functions, but there are a few of them that exist. And one of them is AES encrypt, which we'll talk about in a little bit. There's one called now. There's one called date format. These are functions that exist within MySQL that you can insert into a query to perform some manipulation of data or to retrieve some information from the server. So now, for example, returns in an appropriate date-time format the current time. So this might be useful if you need to, for some reason, insert the current time into a record in MySQL. You might be able to use the now function for that, or you could even use any number of other functions to manipulate now to calculate when 2 days in the future might be, 2 weeks in the past might be, anything like that. Sometimes it is useful to be able to manipulate time like that, and using any one of these MySQL functions will allow you to do it. So there exist these functions that we can use in MySQL to be able to manipulate the data. So presumably there must be a way that we can then pass in some data, like this password data, into a function and get it manipulated in some way as well. And in fact, of course, it's a leading question. We can do this, and that is what login 7 shows us here. So with login 7, it's pretty much all of the same thing, except with pass, what we are doing is we are inputting, or we are accepting as input the password, but we are asking MySQL to encrypt it using a password function. Now, calling this an encryption really isn't correct. This is more of a weak hash. This is not going to be the best way of doing it. This is just an iteratively better way of storing this password in the user. So, do as I say, not as I do. This is better, but it's still not perfect. But you'll notice that as a result, we actually have to use a different table. So whereas before we were using the users1 table, we now have to have a separate table altogether called users2. The reason for this is that the passwords that are stored in users2 are already encrypted. The only way that we are going to be able to test whether a password is equal to a password or that password encoded with this password hash is if that password has already been hashed. Oh man, I'm using the word password a lot. This is going to be confusing. So the only way that we're going to be able to test for this is that if the result of this password function matches what already exists within the database. And when it was unencrypted, presumably the hash using this password function of the text crimson is not going to be equal to the text crimson. So we can't use that same database. We have to create a separate table altogether to perform this function. And indeed, that is what users2 aims to do. And you'll notice that now we have the username still. It's not encrypted. It's not encoded in any way. It's still plain text. And now we can see this password that has been hashed with the password function. And it's this long, crazy string that we might or might not be able to crack depending on our knowledge of it. But frankly, this is not a very strong hash. Somebody who knows what they're doing could take this and potentially pull out the data that was used to form this string of characters. So what happens when I actually run this login 7 is that I enter in my username and password, J, Harvard, and Crimson. And when I hit login, it passes that data in the clear. And again, recall that this password is being sent in the clear from my form over to the server. Then this same function, or rather this same file, is taking this request. It's receiving the password and it's passing it over to MySQL to find out what the hashed version of this password is, and it's using that in this comparison of the two passwords. So just to make this a little bit more real, what we can do is we can actually take a look at what this might look like if I was just performing, if I was looking into this SQL statement itself. And I can do that by just using a select statement. And using select, while you can use select to peer into the data of a table, you can also do it to preview what the result of a function might be. So let's see. So I can select password, and then in text, and then, or rather as a parameter, I will pass it the word crimson. And now what this should result when I hit go is, and hopefully I'm doing this right, is we get the result this, password crimson. Now you can see that because it's encrypted, or rather not encrypted, but hashed this text, you'll notice that this text, and you may not have remembered the whole thing, but you may have remembered the first few characters, the asterisk O2. We can see that this looks similar to what we saw before. So all we're doing is we're hashing this function, or rather we're hashing this data, and we're comparing that hashed data to what already exists in the table to verify that the password is the same. But, like I've been talking about this whole time, using this password function is not very secure. It's not the best way of doing this because it's just a weak hash. It's possible for a user or for a malicious person to, if they view this data, to try to decrypt this information or unhash it and get the original plain text data out of it. And so, as a result, we then need to do something a little bit different. But before I go off on that, I figure I should mention one more thing. This SQL query actually differs in one more important way, and that is that all we are requesting is select one. Notice that we're not doing a select star or a select asterisk, and we're not asking for a specific field. Recall that after select, you can list a number of fields that you want. So I could just put select user, for example, if I only wanted to receive the username that matches this query. Or I could select password if I wanted to find the hashed password that matches this query. Or you can use the asterisk to get all of the fields. But using select one is only going to return one whenever there is a match. So in other words, if I were to actually run this SQL statement in MySQL, for example, and I'll do that here. So I want to select one from users to where, let's see, user equals jharvard and password equals password of crimson. And I hit go on this statement. So essentially all I've done is I've just typed in the exact same query, but pre-populated it with the inputs that a user would supply it. We'll notice that the only thing that is given back to me is this value 1. And in fact, it's only given me one row of this value 1. Let's see what happens if I type in some information incorrectly. So if I edit this, and I just change, for example, the username, now we're not going to get any matches on this query. When I hit go, you'll notice that it returns the empty it returns the null set. There's no, what does it say? Oh yeah, MySQL returned an empty result set. Because I already know the username information, if this username and password matches some information that already exists in the database, I can be assured that the username that the user has sent me is correct. So I really don't need to get the username again from the database. I can just rely on the user's input to remember it if I need to. And all I need MySQL to tell me is whether or not I get a match using this username and password. And using this one query does exactly that. If it provides a single row, then I know, because even though that row has the number 1 in it, it really doesn't matter what the contents of that row is, because when I perform the test in this code, all I am asking is if the number of rows that has been returned from the result set equals 1, and I really don't care what the contents are, then I am sure that the username and password that they have supplied to me is in fact correct. So it's a bit of a shortcut using this select one. I don't actually have to get all of the data from the MySQL server using the asterisk. And when you're performing a lot of queries, minimizing the amount of data that's being transferred is definitely a good thing. And you may say, well, how is data being transferred? Every time you perform a query, these queries are what are called buffered queries. It actually buffers the entire result in memory before it allows you to continue. And if you have a really big query that it just happened and it's storing all of this in memory, that's sort of that's not a good thing. You may want to minimize the amount of memory that's being used, and using this trick certainly helps with that, because we're just performing a small optimization. Okay. Now, going back to this original discussion, though, of the password, where I mentioned that this password function, while better than just having the password in plain text in the table, it's still not very secure. We need a better way of doing this. And in the slide that you had just seen, I had mentioned a function called AES encrypt. And generally, AES encrypt is the way you're going to want to go when encrypting passwords into a table. So we'll see login8.php. It's pretty much, again, essentially the same as everything else, but now we're using a new table called users3. And the reason for that is that we're using a different encryption function, and so the password will actually be stored differently in this table than it did in the other ones. And now what we're going to do is use the AES encrypt function to encrypt the password that was supplied to us by the user. But you'll notice something about this function, and that is that this function requires two parameters. It requires the plain text to encrypt, which is this %s, or the password that's been input to us by the user, and also a secret. And in this case, we've used the word secret. Now, this secret will actually impact the result of this encryption technique. So if I encrypted the same password with secret, and then I encrypted again the same password with something else like not secret, for example, the resulting text will actually be different between the two. So you need to have some known secret across all of your pages that require a login, so that you can be sure that you will properly decrypt or you will properly encrypt this same data every time. Now, if we take a look at this users 3 table, we'll notice that the result or the password field actually looks a little bit crazier than it did before. And the reason for that is that AES encrypt will actually perform a binary encryption. So whereas password will actually give you resultant text that can be stored safely in a text field, in other words, it can be stored safely with the ASCII characters, AES encrypt will not. AES encrypt will actually create a binary string that you have to insert into a different type of data, into a different field type rather. So if we actually take a look, and just to prove this to you, we can actually take a look in the structure of the two tables. So this is the table that uses the AES encrypt function. You'll notice that the password field is of type var binary. It's storing a binary string of maximum length, 255, I think. So we can store a maximum binary string in this field of up to 255 characters. Now, it's possible for, let's see, and I think it might work. In other words, it won't actually give you any warnings or errors if you actually used varchar, an actual text string, rather than var binary. But it's not storing the perfect result. It's not actually going to be correct. You actually need to use var binary every time you're using AES encrypt. Now let's compare that to the structure of users 2, where, if you remember, we use this password hashing function, which actually does create an ASCII safe string. And so instead of using var binary, we can create varchar. Yes?
Is there a way to figure out if you're going to, let's hypothetically say you're going to require 8-character passwords, is that, or minimum and maximum, for example, is there a way of figuring out what the maximum field size you're going to need for our binary?
So is there a way to finding out if you're going to predefine the maximum number of characters in a password that a user can enter? Is there a way of knowing the maximum number of characters that the var binary would use? I don't know.
255 seems like a lot.
Yeah, I did 255 to be safe. I don't know offhand. I imagine that there is, but I don't know what that method would be, besides saying something naive and silly like brute forcing all of the various 8-character passwords. But that's probably unnecessary. I suspect if we look up the information provided to us by the MySQL manual on AES encrypt, that we might actually be able to find out. Let's see. I'm sorry? Oh, it uses a 128-bit key, so we might be able to use that to figure out the final result. Let's see. So usually with MySQL, well, with PHP also, PHP and MySQL actually have really fantastic manuals. Generally, if you have a question like this, it's really one of the things. If you have a question like this and you send it to the staff list, generally what we are going to do is first check one of these manuals. And so this is usually a good way of being able to answer many of these questions. So let's see. Because AES block level algorithm padding is used to encode uneven length strings, and so the result string length may be calculated using this formula, and it actually gives us a formula. So if you have a maximum number of characters in your password, then you can use this to figure out exactly how large of a var binary to use. So offhand, I didn't know that, but again, using these manuals, you're able to, we can find this out very, very easily. But that's an excellent question. Okay, so going back to this idea, again, we have, using this password function, we use the varchar because we can store it safely into an ASCII string as compared to AES encrypt, which, as you saw, will actually store a whole bunch of crazy numbers. Now, the fact that we are storing this AES encrypt data into a var binary actually has some important implications if you decide to move a web application from one server to the next. And what I mean by that is that all of these tables I actually have defined in just a SQL file. And this is a file that is just a collection of SQL statements and in aggregate, it will recreate these tables that you see. And so users3.sql, for example, all it does is it just will recreate the table that you've seen here. But because we have this data that's stored in binary, and we're storing this into just a text file, as soon as we run this file, this is not going to be the same password. And in fact, before lecture, when I ran this users3.sql, ran users3.sql in MySQL to import this data that existed before, and I ran this login8.php file, it kept telling me that the password was incorrect. The password was incorrect. The reason is that this string, this binary string, does not match the actual binary string that was used by AES encrypt. So this is something to keep in mind. If you are going to move or migrate a table that has var binary in it, you need to be really careful about how you move that data, because if you just put it into a text file like this and try to import it elsewhere, most likely you will just mangle that binary data. So it's just something, it's not something that you have to worry about in terms of these projects, but if you decide to move these projects to your own server, for example, this might be something that you have to be concerned about. Okay, so let's go back to this code that we were looking at for login 8. So we're using this AES encrypt, and we're passing in the password and this secret called secret. Now, what we could do is, this secret seems like a good candidate for a constant, right? One of those PHP constants that I could put into a file. But you will notice that if we went back to the MySQL functions list, that there is actually a corresponding function called AES decrypt. And so this function implies that if you pass it in AES encrypted var binary, and you also pass it the proper secret, you will be able to get the plain text out of it. So in one fell swoop, can we undo all of this hard work that we're doing by trying to encrypt this data by using a shared secret like this and putting it into a file and making this file somehow easily accessible or easy to read by anybody on the internet? Anybody that sees our shared secret or that will be used in this AES encrypt function, all they need to do is find out the actual bytes that make up this var binary, and they will be able to decrypt the passwords that exist in this function. So, is there any recourse? Is there anything that we can do to be able to fix this problem? And indeed there is. Most of the time, what you will see is that somebody that uses AES encrypt to encrypt a password uses the password as both the plain text and as the key. And that way, it's always going to be whatever the user enters. And it doesn't matter that we don't know what the shared secret is, because all we are doing, in effect, is comparing the two encrypted strings. We're not decrypting one of them to compare the plain text. All we need to do is compare the encrypted strings. So if we used somebody's password as both the plain text and as the secret, and we get this encrypted string out of it, we insert that into the table. Then we, in order to verify that the user has logged in properly using the correct username and password, we give it the same password and key and password again for the key. Then that string will match, and we will still get a match between the two. So this user will still have successfully logged in without us having any knowledge about the key. We really don't have to know what the key is because we are not decrypting this information. So what if a user enters in a different password? Well, obviously it's not going to be right, because it's going to be a different plain text with a different key, and we are not going to get the same encrypted text out of that. So it still will not match. So this is generally a better way than even this. So take this login 8 and make that secret into another %s and pass in this the same password that you had used the same password that the user has given us as input for their password. And this is how you can create a generally pretty good, pretty solid encryption scheme for the passwords within your account. Yes?
And I'm assuming that when you write the record for the first time, the user creates their password for the first time, you're also using AES encrypt as well.
Right, exactly. So whenever you're inserting data into this, you will use the same function, AES encrypt, and you will be able to do the same thing. So we can actually test for this. So, for example, if we go to back to PHPMyAdmin, and we take a look at the data. So this data right here, this is the user J Harvard and the password Crimson that was AES encrypted with the key secret. So if we try to, and I always get nervous whenever I run live demos like this because something is bound to go wrong. But if I try to decrypt this with AES decrypt, and let's see, am I going to be able to do this? Select AES decrypt password, and the password from, let's see, what is this? Users3. Let's see, then I should be able to see, I need to pass it also the key, so secret as well. And I hit go, and hopefully we will see yes. Okay, good. So in the query, just to make clear what I was doing, you'll notice that I was selecting not only the password field, that's at the end there, but also the result of the function called AES decrypt on that same password field using the secret, or the shared secret called secret. And I wanted to get all the data from the users3 table. And we can see the result here. I was very easily able to decrypt this information just by knowing this shared secret. So if I was a bad guy and I somehow was able to look at the PHP code and I saw that this was a shared secret, then I was able to gain access to this MySQL table. This will be a bad thing. I could decrypt everybody's password in one simple command like this. So instead, let's say that I want to insert data that will use this safer method. So we can use the insert statement. If you haven't seen that, we need to insert data into the table called users3. Is it users3 or user3? I think it's users3. And we want to do values of, let's see, so we'll do John Doe instead, and this time we will AES encrypt with the password Crimson, but use this same password Crimson. Now, hopefully, when I hit go, we will actually get, okay, so it says inserted rows is 1, so I've successfully inserted one row where I have a new user called John Doe, and I've encrypted this Crimson password, but instead of using that shared secret, I now have used the same password, so we can browse this information. And again, you're not going to be able to really see or understand what's going on here, but we could then test to see if this user is logged in by using that same idea and just using the password again in the AES encrypt function. Okay, let's see. Any questions before we move on? All right, so this is how you can create a login form relatively easily. And I just want to say again that you generally don't want to use a secret, but just reuse the password that the person has supplied to you, and you can get a good, relatively secure program. Now, once you've created this, you might want to create a file that can insert rows as well, that can actually create the ability for a user to log or to register rather, and it really is very, very similar to this. You still have to connect to MySQL. You still have to perform a query, but instead of the query being a select query, you would instead use something like that insert query, where you are going to insert that data. And it was gone already, so I couldn't show you. We use the insert into users3 data, users3 query to add somebody to a table. Now first, though, it's generally a good idea to use something like some primary keys on, say, some IDs or some usernames and perform a search just to see if that username already exists, because you don't want to have any collisions. You don't want to have two usernames that exist within your table, one that belongs to somebody with a certain password and certain login information, and another that's the same username and has a different password. This is something that you'll have to take care of. You'll have to be mindful of when you're creating a registration page on your own. And if you can't tell, Project 2, which has actually been released minutes before I started blabbing to you today, has actually been released on the website. You can go and download that and see it, and part of it involves a registration page. It actually involves a login page, it involves a registration page, and you will be using MySQL to create each of these things. You will have a MySQL account on the cloud, then you can use PHPMyAdmin on the cloud to create your tables. You can insert data, but eventually you will have to create a page that will allow a user to register for access to your web application as well. We'll talk a little bit more about this project too in just a little bit at the end of the lecture. So with that, you've seen how you can create an authentication scheme and authentication pages that are actually pretty useful and relatively secure. Now, you might have some other security problems, but really keeping MySQL secure is not all that difficult, so long as you use MySQL real escape string and so long as you encrypt your passwords. You will generally, assuming that it's configured correctly, you'll generally be pretty okay with that, unless you do something really silly in your PHP files. Now, we've talked about some of the different data types that exist for MySQL, and there are actually quite a few different data types. You actually have to make a decision about what data type will be most appropriate for your table when you're creating a table. And it's generally best to use the tightest data type that you possibly can, because every data type that you see here actually has different impacts on the quantity of storage used, on the computation power needed, on how the data is stored and sorted. It really makes a difference to the performance of your application which data types you decide to use. And so you've seen some of these already. You've seen varchar, which is a string type, as you can see at the top. You've also seen var binary, which is a byte string, which is binary safe string, which is up here in the far upper right. And there's other classes as well. You'll notice that I've sort of loosely identified these into various classes, like string types, char and varchar, tiny text, text, medium text, long text. And they get sort of increasingly large or increasingly capable of storing large amounts of data as you go up to integers. Tiny_int is a very small data type. I believe that you can store, 1 byte of information. So I think it's something like -127 to 127, which might be useful for some things, but obviously would not be very good for a user ID, because then you're limiting yourself to about 256 user IDs. Small int, so all of these integers increase in capacity as they go up. Big int is sort of huge. It's very large. I think it supports 20 digits or so worth of it. It's a big number, and unless you really know that you need something that large, you probably want to stick with something a little bit smaller than that. Decimal supports like float. It's what it sounds like. It supports floats, decimals. There's implications for each of these, though. Some of these are actually not good for currency. And again, with this project too, you'll actually be dealing with currency. And it's very important to make sure that you do not have any floating point errors, any rounding errors, anything like that. So you'll have to read the MySQL documentation and determine if one of these are going to be a good data type for you to use, as opposed to doing something else involving integers, converting to cents, something like that. You'll have to make this decision. Date and time, these store different dates and times, as you know. Some of them store only dates. Some of them store only years. Some of them store a combination of date and years. And I have to say that in my job, the differences between some of these date and time types caused the biggest headache that I've ever had, because some of them, so date time, for example, and timestamp, essentially they essentially show you the same data. So they're formatted the same, but the way they're stored is very different. One of them converts the date to an actual UTC time. So it takes whatever time zone it's in, it converts it to UTC and stores it that way. The other one stores the date time as it is. And so if you have to deal with any sort of project that can work across multiple time zones, this is actually a very important distinction, and it's something that you'll have to really have a big headache over when trying to figure out which one is going to be best. To convert it and store it in UTC and reconvert it back, or to do something different and just store it in its raw original format. In the end, I think we ended up storing it in UTC because it was going to be better for us in the long run, but it was a big pain to try to get to that point. Now, sets, this is altogether something different. It's basically like you have a pull-down box in PHP where you can have a predefined set list of options that somebody can choose. So if we were going to implement menu.xml, for example, maybe one of the sets that you would use, and MySQL is overkill for a menu, but just as an example into something that you're familiar with, you might use a set, for example, to determine the different sizes that exist. So you might have a small option and a large option, and that's it. And that could be considered a set or an enum. So using these data types is vital and important in coming up with a good schema for your database. And let's take a 5-minute break, and when we come back, we'll talk more about some of the advanced features of MySQL. Hello, everyone. Welcome back. So before the break, we talked at length about MySQL, and of course, we're going to continue doing that. But to make this a little bit more real, realize that we are actually going to be creating MySQL accounts for you on the cloud, and you will be able to access PHPMyAdmin on the cloud to be able to create your own database, which database, as you probably know, is a collection of tables. And then once you've created a database, you can create a collection of tables. And we will, in the Project 2 specification, tell you what the name of your database should be. And we will also create the accounts for you in the upcoming days. And just so that you know, the original account email that we sent you with your cloud information, hope you've kept that, because the username will be the same and the password will be the same. And when your account is created, which will probably be tonight or tomorrow, let's see, I'm not sure. I'll have to talk to David, see if we will email you if about your account creation. But at least we know that the information will be the same. When you want to log in and start working, you can log in at this URL, cloud.cs75.net/phpMyAdmin. Now it's cloud.cs75.net/phpMyAdmin. And from here, when you hit return, you will be presented with essentially, you should, if you haven't logged in already, you will be presented with a login window. It asks you for username and password. You enter in your username, you enter in the same password that we gave you in your original account creation email, and you will be given access to this PHPMyAdmin. From here, notice that one of the first things you will likely want to do, or at least one of the first things that you will do to get started on your project, will be to create a database. And you can create a database with the name username_something. And most likely, I haven't read through the spec yet because David just posted it minutes before I started. It most likely will be something like your username_project2 or something along those lines, something that makes it obvious that it's part of project 2. Anyway, you can create it here. So Dan Allen _, and then I can create a database name here, and I hit create, and it will actually create a new database from there. You can create tables and insert data into them, so on and so forth. And so this is how you will be able to get started with this. Now, before you can really get started on Project 2, however, we need to start talking about some of the more advanced sort of queries you are likely to see or likely to use even in such a project. So for this, I want to get started with sort of a hypothetical situation. Let's say that I am managing a competition. Let's say just a competition of cars, for example. And so there's various races that occur throughout a year. There's not only various events that happen, but there's also multiple people that drive in these events, and there's also multiple cars that are driven in these events. And it's usually a good idea to keep track of all of this data. Like usually you will want to know, okay, at event X, Y, and Z, driver A finished with the time of this much, and driver B finished it with the time of this much, and driver C finished with the time of that much, so on and so forth, to be able to maintain a history of all of this data. Now, you might be tempted to create a very large table that stores all of this information at once. So, for example, you might have one field that stores an event name. So, I don't know, Boston October race or something like that. And then you might have another field that stores the name of the racer. And then you might have another field that stores the name of the car that racer was driving, and then the time that person did, and so on and so forth. But the problem with this is that you are then going to have a lot of duplicate data, because presumably you're not just going to have one racer that's driving in that event, so you're going to have another row that is going to have the same event information, so it's still going to be named Boston October race or whatever I said the first time. It's going to be somebody else's name, and maybe it's going to be a different car, but you're just going to have a lot of repeat information, and especially if you have multiple bits of information that you're storing about the race, like maybe the time that it took place, maybe what the weather conditions were like, maybe anything else that could be useful or interesting to store and record at a later date. would all be placed multiple times into this. And so there exists this idea of database normalization, where you take this, and essentially all it means is that you take this data that is repeated multiple times and you try to factor it out into multiple tables. So we could very easily, for example, have a table just for racers. So we could have an ID for each of the racers so that we know that racer number 1 represents John Doe and racer number 2 represents Jane Doe, just as an example. And then we could provide any additional information about those racers that we want, maybe an age, maybe how long they've been racing, whether they're novices or not, so on and so forth, anything that's useful like that. Then we could have a separate table for events. So we could have one row for an event that for the Boston October race, and then that maybe also lists the weather conditions, maybe also lists what time it started, the actual date that the event had happened, so on and so forth. And all of these things are useful separately because you can store them only once and later on can you recombine them. And so this exact idea that I replicate in some of the other tables that you might have seen before, cars, drivers, events, and times, where all of these take essentially this idea and factor it out into these multiple tables for us to look at this data. So let's just start looking at some of these. So cars, for example, we might expect to see a list of cars. And in fact, it's useful to separate the cars from the drivers, because what if you have a race where you have multiple drivers per car? Or what if you have a race where they are allowed, for some reason, multiple cars? Having this sort of flexibility by separating out this information really gives, well, I gave it away, but it really gives you this additional flexibility. So we can see that there's quite a bit of information provided here. So we have racing next to, for example, a Volkswagen Beetle, a Ford Pinto, and we can provide some information about each, like the year that this car was made, maybe some additional information, and we could even give it a class identifier. So some cars are going to be faster than others. We could even rate them based on this. We could put them into different classes, which is pretty standard, sort of standard fare for racing, for car races. You might see something like this. And so we can have all of this information available within just the cars table. So what if we move on to something like drivers? Well, here we could input all of the information about a driver, like their name, their age, the year that they've started, anything like this, any sort of information that we might want to put in for drivers. And just to continue along, we could have a list of events that have occurred. So, for example, in 2009, so last summer, there were a couple of events with a description that talks about where these things took place, so on and so forth. Then you could actually have a final table that lists all of the times. And you'll notice that there's some interesting things about this. So we have a driver ID in this table that represents, and presumably this driver ID should match the ID number from the driver's table that represents that driver. Then there's also a car ID. So presumably that driver was driving this car, and this car you can find from the cars table as well. And then there's also an event ID, which brings it all together, which says that this driver was driving this car at this event, and we got, as a result, these times. So if you know that you have a fixed number of times, maybe you are allowed 4 runs total, 2 in the morning, 2 in the afternoon, you can record all of these times, perform averages on them, or what have you, based on all of this information. So if we take a look here, it's going to look not very obvious to us at first blush what this data means. Like, what does it mean that driver 4 ran event 1? We don't know this offhand, but we could recombine this data with the other tables to figure out what the entire compilation actually represents. Now, we use a technique called joins to be able to do this. So joining is a very useful technique where we take multiple tables, we join them together based on some IDs. And these IDs are actually very important. You'll notice a couple of things about these IDs. So if I go back to the structure of this times, for example, you'll notice that I have a couple of IDs in this times table where there's a driver ID, there's an event ID, and there's a car ID. And each of these are underlined. They're all actually keys themselves, so that we can make sure that the combination of the three is a unique combination. So we can say, for example, we've defined an index, a primary key of the 3. So the combination of the driver, the event, and the car are going to be unique, because you're not going to have one driver somehow running 2 cars at the same event. That's just not going to make a lot of sense. But all of these 3 form a unique thing. And having good indices is helpful when it comes to joining them at a later date. It's useful not only to ensure that you are not going to be having any collisions, but it also helps optimize it also helps optimize the join that we will be seeing in just a moment. So to go back to some of these other structures, you'll notice that there is in this events table, if we actually look at the structure, there's a field that I've called ID, and this ID is itself a primary key. So it's guaranteed to be unique. We know it's going to be a unique integer of length 10, and we can ensure that it will be that we can use that elsewhere, and that we are also optimizing it. Same with drivers and cars. Do we have an ID field in each of those representing each one of these rows? Now, if you haven't seen, and you might have seen this, but just in case you haven't, when you create an ID like this in a table, it's usually a good idea, especially if it's a primary key, to also give it this feature here called auto increment. Because this way, when you insert new data into this table, you don't have to know what the latest ID was, add one to that and insert that data into it. MySQL takes care of this for you automatically. So you can just insert the appropriate data without the ID, and the ID will be automatically incremented to be the next highest unique number based on the table. So what if we actually want to perform a join to be able to see a combination of this data all at once? So let's do something that's called an inner join, and I'll explain what that is. But basically, an inner join is the type of join that makes the most sense. It's the join that we'd suspect, where we base it, we use an inner join based on condition. Yes, did you have a question?
How did you visually know which one was the primary key? Because it was the first one listed, or because it was underlined?
No, just because it was underlined did I know that it was the primary key. So their ID was underlined, so it was primary. Times here, you'll notice that 3 of them were underlined, which means that it's generally a good idea to see what's going on with the indices. There is actually a complete list of indices if you scroll down in the structure a little bit, and it tells you exactly what's going on. So we can see that there's a primary key that has a cardinality of 3 with these, and it's made by combining these 3 fields, driver, event, and car. And if we compare that to what we saw in, say, drivers or events, it's all going to look the same in each of these. We'll notice that we have an index here, primary key with the field ID only, so just this one ID. And in this case, the cardinality means the number of rows that are actually unique based on this. So we can see that there's actually, right now, there's 4 uses of the ID in the table. So if we looked at if we browsed the data that existed here, we would see that we have 4 drivers as they exist, and we have an incrementing ID, 1, 2, 3, and 4. And also, if you haven't seen it, another useful thing to do with IDs, because they're generally going to be positive, is to use an integer or an appropriately sized integer and make sure that it is also unsigned. You'll notice that here, one of the attributes is that it is unsigned. Unsigned integers means that it goes from 0 to the maximum of whatever that value is. If it's signed, that means that it's split in half. Half of it is negative and half of it is positive. That's generally, you're just sort of wasting half the numbers in that case. So it's generally a good idea to use an unsigned integer with auto increment for a primary key like this that involves an ID, just because you're going to maximize the usage out of this space. And during the break, there was actually a very good point that was made. That is to actually try to not use some of these more complex data types that you might have seen. Just try to use the simplest one that you can get away with. And it's a very good point that if you actually have to port your program from one type of database to another, it's a good idea to have some of the more basic data types in play rather than some of the more advanced ones that are just, or not really advanced, but just some of the more specific ones that are specific to that are specific to certain products, like MySQL, where you sort of lock yourself into one. So that's certainly a consideration as well when creating a table. Okay, but back to this. We want to perform a join. So you want to do generally, the one that makes the most sense is an inner join, and this is just a join like what we would expect. It's based on a condition. So just to give you an idea of what this would look like, we still use the select query. Now I'll zoom in here. Let's see. All right, so select. And what I want to get in this case is the times from a driver based on any event. I just want to see the combination of the driver's name with the time. So whereas before I just saw the list of times with the cryptic information that looked like, the driver ID and the car ID and all of this stuff, I actually want to see the name of the driver next to their times. And so you can imagine that the way that we would want to do this is to find all of the rows where the driver's ID in the times table matches the ID field in the driver's table, right? So everywhere those two are the same, we want to combine the two rows. So let's do this select. So select drivers.name, and I'll zoom in on this in just a second, and times.star from, and I want to do it from both of these, times drivers where, and I'll explain what all of this means in just 1 second. Times.driver ID equals drivers.id. Okay, let's zoom in. Now notice that we have a typical select statement. And when you have a join, you still have the option of picking which fields you want out of the resultant set. But you also have the additional resolution of defining which fields out of which tables. And that's what this dot notation is. Drivers is the name of a table. So in this drivers table, there is a field called name. So I want to get the name from that driver, and I also want to get, after this comma, all of the fields from times. So what I am seeing is the name from the driver's table and the times, all of the times that are available, or all of the fields that are available in the times table, and I want to get that information from both the times and the driver's table. So notice the important part here, this is what makes it a join, is that you're listing two tables at a time. So you're getting this information from both the driver's table and the times table, and you're setting a condition to perform the actual join, where the driver ID in the times table matches the ID from the driver's table. So if I hit go on this, and maybe if we see what's going on, it will become a little bit more apparent. We can see that we have a couple of rows here. We can see that we have driver Jane Doe, and she's run perhaps 2 events here, but we didn't add in any events information, so we just have to infer from what we've seen here to get that information. So this far left field is from that driver's table. This is the driver name. And because we've set the condition such that the driver's ID has to match the ID that's found in the times table, so we can see that Jane Doe, which has a driver ID of 4, that's what was used to perform this match. And we can find out their times, Jane's and John's, for these different events. So we've combined these two pieces of information from these two distinct tables using a join. Okay, so inner join, this typically is what makes the most sense, but sometimes if you need to do some debugging, or maybe you might actually have to perform a different type of join, there's another one called a cross join. And a cross join is different from an inner join in that it shows you all of the possibilities. So rather than actually performing some condition on it, we just join with no consideration whatsoever. And so if we wanted to do that, we would do an altogether different statement. We would select star from times cross join drivers. And so whereas before we performed a select statement where we wanted to get data from both times and drivers, and we had a where clause that specified how the two pieces of data, or how the two tables were supposed to match together, we were just saying that we want to cross join. We want to get all of the various possibilities between the two. And really, I'm not sure how many times you'll use this, but it's useful for debugging purposes. If you want to see perhaps what is going on a grander scale, we can see all of the combinations that are here. There's this, so this is the section from the times table. There's the driver ID, event ID, car ID, AM run, all of these AM and PM runs. And if I continue to scroll to the right, we can see what is going on. So it's taken the 3 rows from the times table, these 3 rows, and it's combined them with the first row in the driver's table. Then it again took the 3 rows from the times table, so these 3 rows are again, they match these 3 rows, but it combined them with the second row of the driver's table. So this shows us all of the possibilities. That's what I'm trying to say. And we can see we could use this as a debugging tool to compare when the ID from the driver's table matches the driver ID field from the times table, if you have to do some sort of troubleshooting like that. Now, outer joins, these differ from cross joins and inner joins in that they do not require each record in two joined tables to have a match. So just to give you an example, let's do a left join. And what a left join means is that it takes, the end result will be that it's like an inner join. So it shows you all of the joined fields, but it also shows any unmatched rows as well from the left table. And the left table becomes apparent from the query itself. So let's say I perform another query altogether. And this time I'm going to do select drivers.name times.star from drivers, left outer join, let's see, times on times.driver ID equals drivers.id. All right, so notice how this is just ever so slightly different from the inner join that we saw, the one that is perhaps the most intuitive, the one that you might use most often that we saw at the very beginning. Whereas that one, we selected the same data, drivers.name and times.star, from both drivers and times by separating them with a comma. In this case, we're explicitly saying that we want to perform a left outer join. So what this means is that this table, drivers, is the table on the left. And so it's going to perform all of the matches, but it's also going to show us any matches that do not, or it's going to show us any rows in this left table, in drivers table, that do not have a corresponding match on the right. So sometimes you may actually have to perform a join like this, where you need to see all of the matched rows and also all of the rows that did not match as well. There are certainly cases when this would be useful. So if I hit go on this, we can see that I have now some data, and we can see that there are indeed. All right, so we can see that I have the name, these names: John Harvard, Jane Harvard, John Smith, Jane Doe, and Jane Doe. But you'll notice that even though I had some drivers listed here, specifically Jane Harvard and John Smith, they have no associated data with them from the times table. They just do not exist. So you notice how all of this data after their names is null. That data does not exist, but it's still showing us all of the rows that existed in the drivers table. So just to prove to you what's going on, let's take a look at these tables individually. In the drivers table, we see that we have 4 drivers. We have John Harvard, Jane Harvard, John Smith, and Jane Doe, 1, 2, 3, and 4, respectively. Now, it might be easier to remember, because the names are sort of similar, to remember them by their ID. Just remember that we have 4 IDs in this table. Now, if we take a look at the times table, just to see what times these drivers may have gotten, notice the driver ID list here. We're missing 2 and 3. There's no data in the times table for the second driver and for the third driver. And so that's what we saw. Whereas in the very first join, in the inner join, what we saw were only the results that match both this table and the other table. In the outer join, in the left outer join specifically, we got that data, the data that matched, but also all of the rows that do not have a match as well. And that is what differentiates an inner from an outer join. Now, let's see. Let's say that we wanted to actually do something like what I had proposed originally, where we want to recombine all of this data into one huge, massive join to be able to determine what driver drove what event using what car and got what times. So this is going to be a big, massive join, but it's not going to be that bad based on the statements that we've seen. So we're just going to run a SQL statement, and this time I want to get all of the rows. So select star from cars, times, drivers, and events. So this time I want to get the data from all of these tables, and I have to set conditions for all of them to be able to actually join them. So I have to say that, okay, cars.id has to match the times in the times table, the car ID, and if everywhere that I have a driver, so drivers.id has to equal time, the driver ID in the times table, and in the events ID, that has to match the event ID in the times table, times.event ID. Okay, so if we take a look at this, I know it looks sort of long and cumbersome, but really it should hopefully make perfect sense. We're combining the data from all of these tables, so we're selecting all fields from the cars table, the times table, the events table, and the drivers table, and we need to make sure that they can all match in some way. So we have to make sure that we have conditions that can match them all. So the ID field from the cars table has to match the car ID field from times. And the driver ID has to match the driver ID from times. And the event ID has to match the driver ID from times. So we're matching them all through this times table. Now, if I hit go on this, what I will see is this huge, oh no, did I have an error? Times.cars, maybe it was just car ID. I bet that's what I did wrong. I'm going to try car ID rather than cars ID. So it's just a simple typo on my part. And okay, so now we can see this huge long list of data. So we can see that we have, we have driving a Ford Pinto from 1975. We have, with this time, John Harvard, and he is this old, and he was running at this competition, at this event here. So we're getting all of this information just by combining all of this data using a left join, or rather an inner join. Now, so there's some useful information about doing this. There's rather some interesting thoughts that you can have when looking at this information. So if we separate the cars from the drivers, like we said, this implies that you can have multiple drivers to a car, or you could even have multiple cars to a driver in a given event. This allows for that, whereas if you had one big table, you might actually be in trouble with that, just because you might not be able to have enough unique aspects there to do that. So one other thing that or a few more things I want to point out, if we take a look at the cars table, notice that we have IDs 1, 2, and 4, but we're missing 3. What do you think might have happened to 3? Well, it was never driven, or for some reason somebody decided it would be a good idea to just delete the car that was there. So there might have been a car, and let's say that somebody was driving that car, number 3, and got into a big, horrible accident, and they can't fix it, so they decided to just get rid of it. The downside to this is that if we had any rows in the times table that referenced car number 3, we would no longer be able to find out the information from that. We would not be able to do an inner join to determine what car that was. Generally, when you have data like this, it's better not to delete data that has a unique ID, but rather maybe instead you would have a separate field that would be used to determine whether or not it is active or enabled, or in some form like this. So if you have usernames, for example, you might have a separate field that says, yes, this user is active, yes, this user is permitted to log in using some sort of like enabled field or something like that. Or if in the case of this, we could have a field that says is racing or something like that. And yes, it's an active car, it's still going to be racing, or we could name it anything like that. It's generally better to have some field that we can disable it rather than just deleting the row. That's generally not something that we would want to do. So just to prove the point here, I actually have a row where, let's see. What I want to do is now select, using an inner join from cars and times. This is exactly what I had talked about, where the car ID matches the car's ID in the times field matches that of the cars table, and I want to get all of the car information that equals 3. So if we perform this query here, we'll see that we get an empty set. Even though, if we look at the times table here, what we see is that there is indeed a row where the car ID is equal to 3. So we're sort of implicitly losing this data just because we've deleted it from another table. So be very careful when using deletions when you've factored out your tables as much as you have here. Now, you'll notice that we have a couple of things in the drivers table that are perhaps a little bit redundant, like maybe the the age or the year started. And these are not very well-optimized solutions, because what this means is that every year we're going to have to go through this table and update their age. We'll have to add 1. And sometimes it's going to be out of sync because we're just not going to be able to know when their birth date is. So a much better solution to this would be to store instead their birthday, perhaps, and then calculate their age whenever you need to know what it is. And then this way you don't have to redefine it or do anything like that. It's an important design decision that you have here. Now, if we wanted to figure out the number of races that somebody has done, you can do that as well by using something like this. So, for example, let's see. Oops, not structure. So let's say I had this statement instead. Now notice that count, this is another function, count star. And so what I am doing with count star is I am counting the number of rows that I get as a result. So I'm going to select the number of rows from drivers and times where the drivers match from both, and I want to get only the first driver. So I want to find out essentially how many races this first driver has run, and we can see that we've done runs. So if I had some data where I wanted to count the number of races that a person has done, it's something that you don't need to put in the drivers table. It's something that you can instead calculate dynamically whenever you need to. Let's see. So one more thing here. If I go back to drivers, is year started even necessary? It's technically not, because if we know all of the events that this person has driven, we can just look at the earliest event and we can find out what year that is from. And in fact, that's very, very possible to do using only a MySQL statement that looks a bit like this. So this looks, again, a little complicated, but don't be too scared about it. Let me resume in. So in this case, what I want to do is to find out the date that this particular driver has started. So we want to get the events.date. So what we want to find are the dates of the events that this driver had driven from drivers, times, and events where, let's see, where the event ID matches, where the driver matches, and where the driver is equal to 4. So if I do that, if we ignore this other stuff for just a minute, and I just perform this query here, what we will see is a list of all of the rows of all of the dates of all of the events that this person has driven. Now, is it possible for me to get only the earliest one out of this? And indeed it is. What you can do is you can sort the result set. There's part of the SQL, part of the select statement, there's an attribute that you can add called order. Let's see. Oops. So you'll notice it's just pasted here, order by. And so I can actually set a field that I want to sort this data. So I want to order the date ascending, that's what the ASC means, and I want to limit it to only 1. So I want to list it so that I have from oldest to newest, and I only want to get the first result out of that. So all I am going to get out of this somewhat large, somewhat but not really complicated SQL statement is a single event that lists the first event that this person had run. So I really don't even need this year started. I don't need to have a flag in the database that says if the user is a novice or is a first-year driver or what have you. I can just say explicitly that there is. I can just calculate explicitly using this what the first time this person had driven. So when you're designing tables in general, if the computation isn't expensive, leave it out of the database. So like this is not something that's probably going to be needed all that often. It's really not that computationally expensive. This is something that we can do dynamically whenever we need it. The age is the same thing. Store the birth date, calculate the age. You really don't have to store that as something separate. So you want to group logically to decrease the repetitions. Just like what we've done here, we've pulled out all of this logical data. We've separated the events from the times from each of those events, from the cars, from the drivers, and put them into their own separate tables. In this way, we factored out all of this information. And you also want to design primary keys wisely so that you can speed up performance. Joins actually are hit really hard by poorly designed keys. You might want to use the explain statement, which you can look up in the MySQL manual to help you determine what might be going on with your statement. If you notice that your statement is occurring slowly, even though it's a relatively simple join, it could frankly just be that you have some primary keys that are not quite right. So going back to these slides. So we have then joins where you can combine multiple pieces of data from multiple sources into one larger table. That's just a dynamically generated table that you only have access to in that moment. So some of the joins that we saw was this, for example. This was the inner join that we saw originally, where we wanted to do just the most basic, sort of most obvious join that we could think of. That was just to combine the two pieces of data to find out where they were the same. This is the short form for an inner join that look like so right here. We use the short form the entire time. You can just specify the two tables. You can say from one table and join another table, or you can use the short form, which separates the two with commas. Any questions on this? Yes?
Is there any difference in terms of scalability using the short form versus the other join that you were talking about there?
In terms of scalability, I'm not quite sure what you mean.
Does one use less resources than another, or are they both functionally equal?
As far as I know, these two statements that I've shown you, these are both inner joins, and they are functionally equivalent. They're just syntactically different ways of defining the same thing. The primary reason why you might not want to use an implicit inner join like this is that it is implicit, and unless you know the intricacies of MySQL, you may not know that this is an inner join, whereas if you explicitly define it as a join, then it becomes more obvious what it is. And just like what you had seen with the outer join, I explicitly said left outer join, and then it becomes obvious what sort of a join that is as well. Okay, so when we have this idea that we are modifying tables that have been factored out in this way, we can actually come into a problem called a race condition. And if you're not familiar what a race condition is, imagine this analogy. So let's say that you live with a roommate, your spouse, your partner, what have you. You have somebody that lives in the same house as you, and for some reason, you like to, every time you come home from work, you like to have a glass of milk and Oreos. And somehow you know that at home you have no milk, and you know that this other person that lives with you happens to get home earlier than you, generally. So you call up this other person, you say, hey, can you pick up some milk? And you are excited all day, and by the time you get home, you open up the fridge and you realize that there's no milk. So even though you had put in a request and you expected the result was that you would come home and that there would be milk, there was none. This is essentially a race condition where you perform something and you rely on time for that something to be accomplished. And so this is not a good thing in terms of computers. So in the computer world, let's say that you're trying to update one table and you assume that table has been updated and you perform some other change on it. You can actually mangle your data in some way. It's not good to have any race conditions because you're expecting something to have occurred, but it has not yet. And this is not a good thing. And this is especially important when dealing with financial transactions, for example. Anytime you have a financial transaction using a database on a computer, the first thing you should think about, besides currency issues, the decimal points and rounding errors and that sort of thing, the first thing you should think about are, in fact, race conditions. So I guess another example of a race condition is that you get a check, you get your paycheck, and you go to your bank, you deposit the check, and you expect that money to be available right away. So you withdraw $1,000 out of your account, but you are suddenly overdrawn because that check hasn't cleared. That's a race condition. You've assumed that the amount of time that has elapsed has been sufficient for that transaction to have completed before you modify it. So this is a perhaps more real-world way that a race condition can affect you for the worse. And in fact, this can happen if you have a MySQL database as well. What happens if you're going to perform an insert and that primary key that you're trying to insert already exists. So let's take a look at this statement up top, for example. So what we're trying to do is we're trying to insert into a table, we're trying to insert the values 1, 2, and 3 into the fields A, B, and C. Now, if I had just this by itself, and let's just say that for a second that this field A actually is a primary key, so that it can only be unique, it cannot exist. If I insert this value, if I insert this row into this table, and the value 1 already exists in row A, something is going to fail, because you're trying to insert a row that already exists. So this is an example of a race condition. Maybe you have two scripts that are being run at the same time, maybe one by one user and one by another user, and somehow the timing is such that somebody takes a primary key and the other script assumes the same primary key just because it had calculated it at an earlier point, and you try to perform this insert query. One of them is going to fail, and it is not going to be good. So a way that you can fix this race condition is to use this onDuplicateKey update portion. And what this means is that if there is a duplicate key, and in this case there is, because the key A already has the value 1, what we are going to do is update the field C, and we're going to increment the field C by 1. So in this way, you can avoid a race condition in this case. It's functionally equivalent to performing this second part, update table, set C equals C plus 1, where A is equal to 1, assuming that the row already exists, where we have the row with the field A contains a value of 1. So so just to reiterate, A is a primary key. A already exists with the value 1, and if A already exists with the value 1, it is updated rather than having any sort of collision. Now, if you are performing some really big transactions, there actually exists this concept of transactions within certain tables, certain types of tables. So you can have different types of tables that support different features in MySQL. One of them that we've seen the most of is MyISAM. That's the one that you will typically use for most of your things, just because it's very efficient, it's very fast, its storage is good, it's overall the best option. But there's another one called InnoDB, and InnoDB supports the idea of transactions like you see here. MyISAM does not support transactions in the same way. It does support sort of table locking that you'll see in the next slide, but it's not functionally the same. And what this transaction allows us to do is to make sure that we can perform one or more things atomically. In other words, if I am going to take some money out of one account, let's say I'm going to take $1,000 out of account number 2 and put it into account number 1, I want to be able to make sure that I can do both at the same time. So I'm going to start a transaction, and that transaction I'm going to update the account number 2, and set the balance to be $1,000 less than it was previously. And I'm going to, at the same time, update the account number 1 to increase by $1,000. And so with this, you can avoid having a race condition because there's no time in between the two where $1,000 is just sort of floating without actually being in any account. This transaction will only happen when the commit occurs. You notice that there's a commit there's a commit statement here. When commit is run, that means that these two statements will be run atomically, and you will not have a race condition between the two. This compares to using the rollback statement, where if you determine that something bad is going to happen, you can actually undo what you were about to attempt. So in this case, we're going to start a transaction. We're going to update the account number 2 to lose $1,000, and we're going to update the account number 1 to increase by $1,000. And what we can do is check the balance of number 2 to make sure that it is actually correct, to make sure that it is actually something that we expect. If we don't do this, imagine what would happen if, for example, somebody was going to transfer this money and accidentally hit submit twice, for example, and somehow it it is going through the pipes in such a way that one request is received before another, this might actually be a bad thing. You might actually do this multiple times when you don't intend to. You can test, you can perform all tests to make sure that the data has been updated appropriately, and if it is not, you can roll back the statement. So it's as if you just have a big undo statement here. Now, again, InnoDB is useful for this sort of thing, for having transactions, but it uses a little bit more computational resources than my ISAM. It uses a little bit more memory, it uses a little bit more CPU. So unless you know that you absolutely need to use transactions, you might be able to get away with table locks on my ISAM. Now, the downside of using table locks is that it locks the entire table for everybody. The upside is that you can perform then a number of statements atomically while guaranteeing that nobody else will be touching any of the rows within this table, but it does have the downside of locking everybody out until you've unlocked the table. So, to give you an example, we can lock the table's account for write. Now, you'll notice that there's two different types of locks. There's a read lock and a write lock. Write lock is only the session that has called the lock can write to the table. So this is typically the type of lock that you might think of. So it's locking everybody else out from writing to the table with the write lock. Now a read lock, on the other hand, locks everybody out from writing completely. Everybody. Nobody can write anything, so you can only read data. And this might be useful if you're going to back up your table or something like that, and you don't want the data to change while you're backing up the table. You might perform a read lock, but most of the time, if you're going to be doing something transactionally, you want to use a write lock like this. So we lock the table account for write, then we select the balance from, so we're going to test the balance to make sure that it's what we expect. We update the balance in that case, and then we can perform another test to make sure that everything is okay if we need to, and we can unlock the tables. So it's generally a good idea to, in this case, we want to test all of the conditions before we perform the update rather than after. We want to make sure that everything is as we expect. In this case, we want to make sure that maybe the first account has enough money to be able to transfer out of one account before placing that money into another one. Now, all of this comes together in the form of the project number 2, which is called CS75 Finance, where you are essentially creating like an E-Trade or like a Fidelity sort of account system where a person registers for an account, they're given a certain amount of paper or fake money, and they can buy or sell stocks. And you are going to keep track of the stocks that they buy, keep track of the sales that they stock, and manage their portfolio. You'll be able to figure out, you will tell the students, or well, not the students, but you will tell whoever is registered for your website whatever that they bought, how their portfolio has changed. So maybe in a couple of days ago, I went to your website and I bought stock from Apple, for example. And then I wait a few days and I go back to your website and you can tell me how my portfolio has changed, whether it has increased because the stock has gone up or decreased because the stock has gone down. And you'll have to read through the specification to find out exactly what you have to do. But generally, and you can take any method to approach this project that you want, but generally I would recommend, if you're stuck, to attack the project in this manner. And again, the project was released minutes before I started, and this is what I generally tell people, so maybe some features have been added or removed from this list. This is something that I've mentioned in previous semesters. It might change slightly, but generally, this is sort of the attack plan that you might have. The first step for you to do will be to implement the login information. So very much like these login pages that you've seen, where you access data from a table and you verify that a user is logged in, that's a good step to start with, just because you're starting the framework for your project. Then once you have that, then you can grow it so that they're able to register, so that a person that is not actually a member yet of your website will be able to register for an account and get a certain amount of cash for free within their account. Then from there, you will want to be able to implement getting quotes. So there's a way that you will be able to retrieve quotes from I think, what is it, Yahoo Finance or Yahoo Money, whatever that site is called by Yahoo. I'm pretty sure it's Yahoo Finance, where you actually can retrieve quotes based on stock symbols, and that's a good thing to get next. So a user will enter in a symbol, you will retrieve the quote and display it, and that's generally a good thing to do after they register. Then you'll try to figure out how to sell a stock. So if a person owns a stock in their account, how can you sell that and put cash back into their account? Then after that, you have to do the opposite. Maybe buy the stock. So once they get a quote from a symbol, they'll maybe want to buy that stock, and how do you implement that? Now, I don't know if history is necessary to implement, but in case you have anything like that in this project, then you might implement history next, and any sort of nice or fun functions or functionality that you want to implement would you attempt after all of this core functionality is placed instead. So with that, you have a lot of information now on SQL and on joins and all of these neat, fun topics. And I think you're really going to enjoy this project too. And with that, go ahead and get started in that. Good luck, and I will see you. So I won't see you next week. David will be back next week, but I will be back in 2 weeks, and I will see you then.